review how to do this, I'll link to a video. All right, so today we're covering what we call limiting reactant. And the way I like to introduce this is with sort of a little analogy. Let's imagine that you are a bicycle maker, making very simple bikes. So to make a bike, you take one frame plus two wheels. And again, we'll keep it so simple that it's just this stuff. And that's going to yield one bike. Now, what if I told you you had 50 frames and 125 wheels? How many bikes could you make? 50. Okay? So you're going to use up all 50 of your frames, and how many wheels are you going to have left over?
25.
25, right. So this is the idea of a limiting reactant. In the real world, something's going to always run out first. In this case, your frames are going to run out. So you're going to use up all 50 of your frames. You're going to end up with 50 bikes and 25 wheels left over. The thing that runs out first, we call the limiting reactant. Because the equation is limited by how much there is. Once it's used up, you're done. And we want to guess what we call this other part? Excess reactant. Very good. So make sure you know what these terms are. Limiting reactant and excess reactant. Sometimes you'll see these called reagents as well, but I prefer the term reactant because reactants are on the left side of the arrow, products are on the right side of the arrow. So here's the problem that I want everyone to copy down, please. 15 grams of calcium hydroxide reacts with 24 grams of nitric acid, HNO3. And there's three questions we're going to be asking. What's the limiting reactant? What's the excess reactant? And we're going to complete something called a mica table to calculate how many grams of everything is left. So copy this down, please.
Everything?
Yes.
Yeah, she does. She does.
Now be warned, these problems will take a lot of space on your paper. Notice homework tonight, 2 problems, and I gave you a full page for each. So you'll need a lot of space in your notes. I'm probably going to take about 7 or 8 slides to complete this problem. So the quiz we're having, you could probably expect maybe one of these, like one full problem. Like if I just ask you steps 1 and 2, you could get that in about 5 minutes. But that third step takes a while, which we'll talk through.
So,
Yes, Tim?
is a smaller amount like always going to be the limiting reactant, or in some cases is that
No.
not the case?
Because it all depends on moles. Like we're gonna have to convert both those things to moles,
Whichever is the less one.
and it's not even that. Because I could have like 2 moles of something and 3 moles of something else, but it all depends on the coefficients as well. It's really tricky. Okay, take a little bit more time, and then we're gonna move on. All right, here we go. So the first step that you're going to do in these problems is nothing new. It's what we've been doing in the first step of every problem, which is write a balanced equation. and then copy down the coefficients. So that's your mole ratio.
Is this the instructions for how to solve the mole?
This is like all of it. We're going to do it all in a bunch of giant steps. So we had calcium hydroxide. Someone tell me the formula for calcium hydroxide.
Ca parentheses OH and then
Very good. Calcium hydroxide reacts with nitric acid, which I told you what it is. It's HNO3. It's also known as hydrogen nitrate when it's not aqueous. And that's going to form, well, let's talk about it. What type of reaction are we looking at here? Very good. So what's my calcium going to mix with? Right, so we're going to get calcium nitrate, so Ca parentheses NO3 close parentheses 2. What's my H going to match with? OH, so I'm going to get HOH, also known as water. Okay? And I'm going to actually leave this as HOH. I prefer this because it makes it easier for me to balance. Now, remember, normally we have to like check that solubility table. If I give you a problem, I'm not going to throw a curveball. It's going to go through. So something we can, this is going to be aqueous, aqueous. That's going to be aqueous. And this isn't going to be solid. It's going to be liquid. Now, normally we looked for a little S for solid. But I said it could be a solid, liquid, or gas. If you have liquid water, that's technically water precipitating out. So this is a reaction that takes place. And now we have to balance it. So could someone tell me where I need to put coefficients? Parth?
Right, there has to be a 2 in front of the HNO3, and then a 2 in front of the HOH.
Very good. And this is why I really like keeping it as HOH, because I can see I need 2 hydrogens, 2 hydrogens, 2 hydroxides, 2 hydroxides. If you leave it as H2O, you're going to have to like split all the nitrates up, and it gets a little confusing. So, nothing new. We've written our balanced equation. We're going to copy down our mole ratio, just like this. Okay. Step 2. Convert both reactants to moles. Again, nothing new. This is just what we do for a grams in, grams out. So going back, I have 15 grams of calcium hydroxide. Wow.
Oh God.
That's a G, okay? 15 grams of, let's just get this down, CaOH, close parentheses 2. Can I get both of these tables to compute this for me? Convert that to moles, so we'll compare. 15 grams calcium hydroxide. Other table, we're going to do 24 grams of HNO3. Could I have both of these tables and on the side compute that, calculate that to moles? How much? 70.1?
Is that 150?
I think you're going the other way. The mole should be a lot smaller.
What is that?
I'm not
Is
finished.
that 150?
Okay.
So,
Oh, that's molar mass.
yeah.
What is that, 150?
No, that's 15 grams. Sorry, my G bugged out here.
Sorry about that. Yeah, do that. Let's like really focus on it.
0.2 something.
Explain this to like what, like
Yeah, 0.202. Mole.
Did you guys get this answer?
I wonder if anyone's based that.
Did we get an answer here?
Yeah,
Parth, what'd you get?
I got 0.38107 moles.
0.38107?
Yeah.
I'm going to call that 1-1. You can cut off the sig figs where you want to until the very end when you have to limit it, but 4 works for me. Can we double check these against what I did? Yep. So, converting grams to moles. All right. Step 3.
Wait, right now.
I'll go back in a second. So copy these down, please. We've converted both reactants to moles. Yeah, 0.3811.
Is that by 24 grams or is that by what?
That is the moles, yes. And I should write this. So that's moles of HNO3, moles of CaOH2.
Wait, what?
No. Especially in class.
Okay, we are going to be moving on. Remember, you're expected to know how to do this, so we don't need to like write how to do this. Step 3, plug these back into your table. So we had 0.202 and 0.3811. So right here, 0.202 and 0.3811. So basically we just converted the grams back to moles and plugged it in. So what we're going to do now, pick either one of those pick any one of these products, and you need to find out how much of it I would get if I had like just this, ignoring this, and how much I would get if I had just this, ignoring this. Okay? So let's choose this one. You can choose whichever one you want. In fact, let me write this down. We'll get all the steps in order. So step 4 is pick one product. Calculate how many moles you get using each of the two reactants. We're going to do two separate calculations here.
Country music is worse.
Mr. S.
Yep.
What do you? I know it sounds like a dumb question. Calculate how many moles you get using each of the two reactants.
We'll go through it. It'll should be a little more clear.
Like, what do you mean by plug it back into your table?
I just mean take these numbers that you get and put them down here. Remember that? All right. So here's what I mean by this. I need to find out how many moles of calcium nitrate this would get me. And then I need to find out how many moles this would get me. And whichever one is the fewer number of moles, that's going to be my limiting reactant.
So you pick one of the products and you do it for both of them?
Yes.
It's the same product?
Yes. So here's what I'm going to do. Let's see. Yes.
How come can you only do CaOH2?
No. Sorry.
Like,
I cut you off.
you said you could do calcium hydroxide to calcium nitrate, but you wouldn't be able to do calcium hydroxide to
Water. You could pick either one of these, but whichever one you pick, you have to take both of these and compare to that. You'll see what I mean in just a second. Trust me. So, to find out how many moles this would produce into that, I'm going to say 1 over 0.202 equals 1 over x. Now for this, you don't even have to do the cross multiplication, right? If the mole ratio is 1 to 1, what's my x going to be?
202.
Right, because if I have 1 over 0.202, that has to equal 1 over 0.202. So here's how I'm going to write this. I like to add a little step to my table here. Using CaOH2 equals 0.202 moles of CaNO3 2.
Mr. S.
Yes.
So when you convert reactants to moles, does that mean like reactants means like the original the
These are called the reactants, these are called the products.
and you don't class the moles from the products? Or is that
I do, I did right here. Okay, let me go through this next step. So we found out how many this is going to produce. Now we need to find out how many this is going to produce. So using HNO3, the formula we're going to use is 2 over 0.3811 equals 1 over x. And now we do have to cross multiply, so 2x equals 0.3811, so divide 0.3811 by 2. And this is going to give us 0.1906. Or I'll call it 0.191 moles. So we've calculated how many moles of this I would get using each of these reactants.
Wait, okay. Yeah.
And notice for each of these I ignore the other one, because we're assuming if it were in excess. Okay? Let me skip ahead
Wait,
and
so-
list step.
So do you add those together or
No.
something, or?
Yeah. So you do each one to the same.
Each one to the same product.
Okay. So now what have we found out now?
Let me write step 5, and it'll be clear. Step 5. Whichever reactant produced less of that product is your what? Limiting or excess reactant? Limiting. The other one is your excess. Yes, Carl.
So you put in CaOH2 into CaNO3, and then you did the same with HNO3.
Yes.
Does it matter if you do it to HOH?
Nope. Just choose either one of the products.
When you would say that HNO3 is the limiting factor, would you just say HNO3 or 2HNO3?
Just say HNO3,
Okay.
nitric acid.
Mr. Ash,
Yes.
can we go back to
Yes,
the
we will.
It's a long problem. It's a lot of stuff.
Yeah, I'm still up on it.
Well, good. There's a video you can watch. We good on this? All right. So looking back, using calcium hydroxide, I produced 0.202 moles of calcium nitrate. Using nitric acid, I produced 0.191 moles. So which one of these is my limiting reactant?
Using HNO3.
The H&O.
Right. So since I produce less using this, I'm going to write HNO3 equals limiting reactant. So therefore the other one is my excess reactant.
Mr. S,
Yes.
how come we don't use N what is it, 2HO2 for we don't put a line and then
I can't
write
remember.
out. This is a question on
We could choose either one of these products. We happen to choose the first one
so you can solve it using either one.
using either one. Yes.
So HNO3 is the limiting because there's less moles.
HNO3 is the limiting because when it goes through, it's going to produce less calcium nitrate than calcium hydroxide will.
When you do this,
Okay. So we just answered steps 1 and 2. What's the limiting reactant? What's the excess reactant?
Got it.
when you do the equation stuff, are we ever gonna have it where it's like decomposition or something, where there's only one
Yep.
reactant?
Good question. No,
So
there's
it's
no
always-
limiting
Okay.
for that.
What if it was like synthesis, would it be like that?
Then yeah, I could give you synthesis and you would just have one product to choose. Okay? So notice I now say complete what I call a mica table, which we'll go into, to calculate how many grams of the excess reactant and each of the products are present at the end. So here's what we do for this. rewrite equation. So CaOH2 plus HNO3 yields CaNO3 plus HOH. Plug the numbers back in. So here's what a mica table is. The M stands for mole ratio, which we've done plenty of times. Rewrite the coefficients. 1, 2, 1, 2. The I, excuse me, stands for initial.
Do we have to know what it stands for?
No. Well, I mean, it helps, but I'm not going to ask you. Initial, C is change, and the A is after. Sometimes you'll call it a mice table with the E being end. But either way, here's what I'm looking for. So the mole ratio, we just copy down the coefficients again. By the way, this entire table is going to be moles, not grams. Okay? So we want to know how much of everything we had initially. So take a look in your notes. Could someone tell me how many moles of calcium hydroxide we had originally?
0.202.
Right? 0.202. How much of this?
0.3811.
Good. How much of each of these products did we have initially? Before the reaction took place? Kind of a trick question.
We didn't know.
0, right? Before the reaction took place, we had nothing. Okay? So we filled out the initial. Now we're going to fill out the change. So which of these was my limiting reactant?
HNO3.
Right. Before I fill this in, question?
No, it's not there.
Okay, good. So how much of my limiting reactant is going to be used up?
All.
Good, all of it, since that's the one that we're limited by. So we're going to say minus 0.3811.
Because we use all of it, that's why it's
Absolutely. Now, we already calculated how many moles of this we're going to produce. Could someone look back in their notes and find that? Point what?
191.
Remember, we figured that out to determine what our limiting reactant was. Okay? We now have to figure out how many moles of water we're going to get out of this. And there's two ways of doing it. You could set it up with the something over something equals something over x, or you could just look at the mole ratios. What's my mole ratio between nitric acid and water? 2 to 2 or 1 to 1, right? So for every mole of nitric acid that gets consumed, how many moles of water do I get? 1. So I'm going to write the same thing. I'm going to say plus 0.3811.
Question.
Yes.
The 0.191, is that what we got when we, that's like the excess?
No, that was, let me go back.
Yeah.
When we worked this out, we said using HNO3 we would get 0.191 moles.
Okay.
Stress.
Yes.
So do you only, for this, do you only write the limiting?
Yes.
So the excess just.
Oh, well, we're going to work that out next.
Why? Oh.
Okay, this next part, please pay attention. This is by far the trickiest part. We're going to find out how many moles of our excess reactant was used up. Do you have a question before we get there?
Why is there none for the CaOH2?
We're about to do that. That's our excess reactant. We're going to figure out how much of that was used up. Because that's,
How do you
it's
get the second point?
Why are you
381?
adding?
2 moles
Yeah.
to 2 moles means it's a 1 to 1 mole ratio. So for every mole of this,
Yeah.
1 mole of that forms. If I didn't choose to do it that way, here's what I would do. I would say, I would look at my mole ratio, and I would say 2 over 0.381 equals 2 over x.
Oh,
Okay?
okay.
But you don't have to do that if it lines up nicely like this. We're just going to say plus 0.3811.
Why are you plussing it?
Because we had nothing and we added this. It's forming.
So you're getting
Yes, last question, and we're
So
moving
does
on.
that mean the CaOH would be 0.191? Because it's 1 to 1, minus 0.1.
Yes.
Yeah.
Nice way to look ahead. There's two ways of figuring this point out. You could either work it out using another one of those number over number equals number over x, or look for another mole ratio. Use this mole ratio as like your shortcut. For every mole of this, how many moles of this was consumed? 1. Okay, so it's 1 to 1. So if 0.191 went into it, it's going to be minus 0.191 coming out.
Why? Oh, did you do 0.202 subtracted by 0.3?
No, I didn't. I think I may have. It worked. Yes, but that's not why I did this, Tanner. I did it because I looked here. It's a 1-to-1 mole ratio. So if 0.191 moles of this came out of the reaction, 0.191 must have gone into it and been consumed. Okay?
Got it.
The other way you could have worked this out, if I didn't, because sometimes you're not gonna have any repeating numbers, which kind of stinks, but sometimes it happens. You're gonna have to use your mole ratio, and what I'm gonna say is, 2 over 0.3811 equals 1 over x. Notice we don't use this because even though that's how much we have, that's not all going to react. Only some of it is. So compute this, it comes out to 0.191. Okay?
And if it was a 2-to-1 ratio, that means just double it, or double point.
It would be,
If this was
take half of this.
Oh, got it. Okay.
So, we've come a long way. We're almost done. A is after. How do you think we're going to figure out how much it was left? Subtract or add. So 0 plus this gives me 0.3811 moles of water. 0.191 moles of this. Yes?
Okay, so for the product, do you always add and then for the reactant?
Yes, because the products are formed. They came from nothing. They formed. These were consumed. So, this minus that is going to be 0. Someone with a calculator, what is this minus this? Alex. 0.011. We have now figured out how many moles of everything have formed. I'm going to have a little tiny bit of calcium hydroxide left over. I'm going to have no nitric acid left over because it was all used up. And I'm going to have that many moles of each of those products. Now, since I am asking this question, we should probably cut these sig figs to 3. But what is my last step? Did I ask for the moles? Of course not. I'm asking for grams because we live in a world of mass. So, final step. Convert all of these back into grams.
Do we really need to learn that?
4 hours.
I'm never gonna do this in your real life.
This side of the room, convert this please into grams. This side of the room, please convert this into grams. The 3 of us will compute that into grams.
Which ones are who done?
You guys do the middle one. Convert that into grams.
Well, that's the hardest one.
Are we doing the second one?
Good.
Easy one.
It also restarted. It also restarted. Yeah. It restarted.
Anyone have an answer?
It takes so much to turn
Yeah, it just overloaded.
8-1 what? You guys know the camera's picking up everything you're saying. I'm just
Oh God. Why don't you delete the audio, Mr. S?
So does anyone
There's
here?
some worse things we
Parth, do
said.
you have an answer for me? Anyone on this side have an answer?
Almost, I got 31.327.
31 point what?
0.327.
0.3 or 0.4 depending on how you round it off.
It's just 3 with like that.
We've done it.
We've done it!
We've solved the problem. We took 2 substances, we found out how much of everything you get. By the way, if I were to ask for the 4th one, how much nitric acid do we have left over?
0.
0, of course. We've finally done what I like to call real chemistry for the real world.
This
What sucks when you
Alright,
Who said that? No, don't say that, bro.
now that you guys know how to do this, and you don't have to copy down notes in between, these 2 problems should take you no more than 30 minutes, which I think is a reasonable amount of time.
Comment, like, and subscribe.
There are some repeating ratios, some not. Hey guys, I do not see you tomorrow, so this video will be up. Let me in fact stop this.
Edit it.